Hello everyone. This video is going to be the first video in the series of transformer-based SLAM learning. Today we will be talking about PyTorch foundations, and what you see on your screen is a document that lays out the whole plan phase by phase. And starting phase 1, today we will be seeing about PyTorch tutorials. I will be sharing this document with you. Please check in the description below. And without much delay, let's just jump into it. Get started with PyTorch. Looks like a good place to start. And let's jump into quick start. Okay, so here the first thing that we do is import torch module. We'll be using Google Colab, because it's really easy to use. And I'll be sharing the Colab notebook file also with you guys. So let's quickly run this. Okay, looks like it is done. Now, the first thing that we're going to do is to initialize some data sets. So Torch has some inbuilt data sets, and we're going to be using fashion mnist dataset, which is just a set of images. Let's go back to Colab, and so what we are doing here is we are creating two different sets. One is the training set and one is the test set, and apparently the inbuilt dataset that Torch has it also has some parameters where you can specify if it's going to be the train set or the test set or maybe otherwise. So let's run this. Our dataset is downloading. Okay, it's done. Now the next thing that we're going to do is pass the dataset to data loader. Okay, so data loader is something that helps us load our data one by one. So basically iterates over our data set. So we're going to be initializing some data loader. Okay, and we are also going to print some detail about our data. Okay, here we have it. So our data n is the batch size. What I see here, n64 is the batch size. C is the channel of the data. So in this case we have grayscale images, that's why our channel here is 1, and then this is height and width of the data, which is 28 cross 28. So if you see here, the way we constructed our data, which goes into X, right, is like it is 4-dimensional tensor, with first dimension being batch size, second one being the channel, third and fourth being height and width. Okay, so let's move ahead. The Y is of size 64, so these are our classes. Now going back to the module, next thing we're going to do is create the models. Okay, so in the first two lines, what we're doing is we are specifying a device. It will take GPU if it's available, otherwise it will take CPU. And here we define our class of our custom neural network, which is inherited from neural network.modules, and that's how it's normally done. So this is one good thing to note. Here we're specifying how our model looks like. So we have 1, 2, 3, 4, 5 layers. First, third, and fifth being fully interconnected layers, and second and fourth being the activation layers with ReLU activation. And the function forward is used for iterating over the data set. It just moves the training forward. So what we are doing here is we are flattening out the input data. Flattening out means we are making it into single one-dimensional vector. We are getting some logits from the output. So linear ReLU stack X, return logits. Let's see how this is working. Okay, so first let's define our class. Okay, we have our class defined here. So linear ReLU stack, this thing, what this does is that it does a forward pass and returns, gives the logits which we are returning for overall forward pass. So basically what we are doing, the process of doing a forward pass is we flatten out our vectors. We do a forward pass with whatever our model is and give the flattened vector to it, and the logits that are returned, we take back the logits. This here linear ReLU stack, this module is especially like it's a convenience made into the torch module in case your model has alternative ReLU activation layers. So this is a convenience module for that. So it just understands that your model is structured in this way, and it's just an easy way to call this model. Okay, so far we have created our model and created a forward pass function. Next thing is we are going to change some model parameters. So in this case, we are going to be specifying our loss function and the optimizer. So let's go ahead and do that. Okay. Now the next thing is we are going to be creating a training and the testing loop. So the function basically that goes into the loop for training and testing. So let's go ahead and do that. Okay, so our training and testing loop is, the function is ready. The loop comes next. So here's the loop. Okay, so now let's see what we have done. So if I play this, it's going to start training. I will not do that, but before that, let's see what we have done. So epochs, total number of epochs we have specified as 5. And for each epoch, it does the training and the testing. So while training, we pass our data loader, we pass our model, we pass the loss function and the optimizer. Okay, and the train here is this function here, train. Test here is this function here, test. So let's get into it and see what's happening. So from what I know, this puts the model into training state. Okay, so generally we have two states of the model, training state and the evaluation state. So this puts the model into training state. It tells the model that, okay, now the training is going to start. For batch, an XY in an init data loader. Okay, so here we are iterating through our data loader, sending our input and output tensors to the device. I'm not sure about how this is working. Although overall on a very high level, I know that this is doing a forward pass and this is calculating the loss, but let's see more about it. So it is what I thought it would be. The line, this line paired model X is doing the forward pass, and then the loss is being calculated in this function. So okay, so what's happening here is this is giving out the predictions, and maybe you might be knowing that how loss is calculated is the difference based on the loss function, of course. The difference between the actual value and the predicted value is calculated in the loss function. So that's the main idea of loss function. So this is giving the predicted value, and this is calculating the loss function using the specified loss function that we specified here in the cross entropy loss. Okay, so and here is where the back propagation is happening, as you can see. And once the back propagation happens, this is doing the optimization. Like for example, what we saw, we have chosen our optimization as stochastic gradient descent. So this is these two steps are doing the gradient descent calculation, and this is nothing but printing out the loss each iteration. Okay, then we move on to the test loop, and if I'm not wrong, test loop must be doing the same. We have our data loader. We are putting the model in the evaluation mode. Here we put the model in train mode. Now we are putting it in evaluation mode. Now so here again, more or less the same thing is happening. We are sending our data tensors in input and output to the device, doing the prediction, calculating the loss. Okay, and this we are just using to calculate the accuracy, just to evaluate how much is the accuracy. Sorry guys, due to technical issue, maybe in past few minutes you would not have seen the face cam, but anyway, let's continue. Okay, now that we have our train and test functions, we have our training and test loops. We will run the last snippet of the code which will actually do the training. Let's jump into it. Okay, so the saying train is not defined, so I'm not sure, maybe I'll have to reload the whole thing again. Okay guys, so I ran the script again. I had to load it all again as the session was disconnected. And now we can see the training happening for the first epoch, and here are the losses being calculated. And now it went into second epoch. We will get back when the training is complete. Okay, so the training is complete now, and we see that our accuracy is about 65% and average loss is about 1. And I think that concludes the first quick start of today. We do have a few more things about saving the model, loading the model. Okay, let's just let's just quickly do this and then maybe we can finish today's session. Let's try this out. So we'll be running the code snippet for saving the model. It's torch.save, and then you have your model, which was defined here. Where was our model defined? Model here, right here, this one. Okay, so we take the model and we save the state, and the file extension will be PTH. You can give it any name. So let's just go ahead and save. Okay, so it's saved now. The next step is loading the models. Let's try to load the models. Saved model. So we have our model name, same as this one. Model neural network to device. Model neural network to device. Model load state. Okay, I don't know what this does. So let's try to look for it. Okay. So what this is doing is this part is just initializing the neural network, and then this part is specifying that okay, we want to put the architecture of this neural network to device, whatever our selected device is, so that we can start, I mean our device can be ready to use this neural network. Okay, and then we load the model. I think that's about it. Let's run this. Okay, model is loaded to make predictions. And this is the final step where we are going to use the model to make predictions. So these are the classes apparently that we have. Model is put into evaluation state again, not training state, because we're not going to be training it. Okay, so what we are doing here is we are just loading the test data, and this corresponding value is the output value. Okay, and the output value we need to compare. We just need to compare if the prediction is correct or not. Okay, and with torch no grad, there's something very important. Let's see what this does. Okay, so this is the most important part. Block any operations performed inside torch no grad will not build the computational graph necessary for backpropagation, which is not necessary. So model does not need to do any backpropagation. So any code defined within this, which means this, will not build the computational graph necessary for backpropagation. Okay, so basically the backpropagation will not happen as long as this is defined for any of this function. Okay, especially like here when we are doing the prediction, that's the main thing. That okay, so let's run. We got the right answer this time, even though our accuracy was not very much, 65%. We got the right answer this time. Again, correct, browser. Correct. Okay, so in general, looks like it's giving correct prediction. Maybe the overall accuracy is 65%, but so far whatever we tested for whatever data we have, it's giving the correct prediction. So that's about it for this session about the quick start basics of PyTorch. This was easy. So we learned about how to create the training and testing data set. We learned about the data loaders. How do we load the data set? Okay, so what we have to notice here is that as long as your data set is defined in PyTorch manner, we'll explain more in detail about how we define data sets if it's something very custom and not a data set from Torch. But we'll see that we'll be learning about that later. Even I don't know much about it at this point. But yeah, as long as we have that data set in Torch format, we can load it very easily. And then we also saw about specifying the device for using. We got to know the basics of how we create our network. We saw how we do the training and testing, how we write the training and testing loops, and then we did a sample training and we got the outputs as well. We also learned how to save the model, how to load the model, and how to do predictions. So this was a very basic. I also this was the first time for me also going to this basic level, and in future we'll hopefully learn more and more about how all this works in more in detail, but so far it has been easy. And yeah, next session will be on implementing linear regression and CNN manually. Okay, so what I will be doing is I will not actually be implementing a linear regression. I've done that before and I feel like it's not very important. So let's try to implement a CNN manually next time. Okay, so that's about it for today. Thank you everyone for watching.